All right, so starting with right triangle trigonometry, the first thing I want to define is a right triangle, and you know what it is. So somebody tell me, what is a right triangle?
It has a 90-degree angle.
It is. So this is a triangle with a right angle. And we defined right angle last time as being a 90-degree angle. What's the hypotenuse then? It is the longest side. And specifically, the longest side is where? Opposite the 90-degree angle. So this is the side opposite the right angle. And then what is legs? What does that mean?
The other two sides.
That's right. This is, I'm going to say it exactly like you just did, TJ. That's good. These are the other two sides. And, of course, your image looks something like this, or this would be an example of one. At least if I draw it well, it will. And there's this 90-degree angle down here at the bottom. Now, I haven't noticed this, mentioned this notation, but I think you've seen it before. The right angles are marked with the corner on the box. If you don't see a corner in a picture, you can't assume it's a right angle. All that sort of stuff that you've remembered from math classes along the way. Who remembers the Pythagorean Theorem? Awesome. So that's usually how we remember it. A squared plus B squared equals C squared. But what are A, B, and C?
A and B are the sides and C is the...
Okay, so A and B are what we called in the previous screen the legs, actually, right? That's an E in there. And the C is the hypotenuse. Okay, so again, if I draw my picture, then I can have, oops, that's not going to work. Let's try this. Here's A, here's B, and does it matter which one I call those?
Yeah.
Nope, doesn't matter in the slightest. I could switch them if I want. C is the hypotenuse. That one matters. It actually has to be in that location, of course. All right. Have you seen SOHCAHTOA before?
Yes.
Good. If you haven't, it's no problem. SOHCAHTOA is an acronym to help you remember the trig functions. So if you haven't seen it, make sure you're writing down what I'm saying. I don't have space on here to write this down. But SOH, S stands for sine, O stands for opposite, and H stands for hypotenuse. So if you're taking a look at this particular diagram, I would say, let me give an angle. I need it somewhere, so I'm going to put the angle down here, theta. This is my right angle here. Okay. And according to where this angle is located, this would be my opposite side because it is opposite that angle. The angle beneath it is the adjacent side. Adjacent means touching. It touches or is part of that angle. And the hypotenuse is, of course, the side opposite the right angle. In relation to this description for the acute angle, theta, sine of theta is the opposite over the hypotenuse, hence SOH. So, okay. The ka is for the cosine. The cosine is the adjacent over the hypotenuse. That's the ka in SOHCAHTOA. And I'm skipping a couple. I'll come back to my promise. Down here, tangent is the opposite over the adjacent. That's the TOA at the end. There's three that I didn't fill in. I did not fill in CSC, which is cosecant. I did not fill in SEC, which is secant. And I did not fill in COT, which is terribly written here at the bottom, which is cotangent. All right? Let me start with cotangent since I've already got my screen down here. Cotangent and tangent are related. They're what we call reciprocals. And if you'll remember what reciprocals are, is that you flip a fraction upside down and you have its reciprocal. All right? It's also sometimes referred to as the multiplicative identity of something. So the reciprocal here for TOA, for tangent, instead of it being opposite over adjacent, it would be
Adjacent over opposite.
adjacent over opposite. So if I have one of them, I should be able to find the other one relatively easy. The cosecant and the secant are not paired up like tangent and cotangent. The language doesn't work very well. But what I remember and how I remember it is that each one goes with a co of the other one. Sine goes with cosecant. One of them, cosecant, has the co in it. Sine doesn't. So I've got cosecant, and it relates to sine. That's why I've put them beside each other right here. And it would be the reciprocal of sine, which would make it what? Hypotenuse over opposite. Likewise, we can put the cosine, co, and secant, it doesn't have a co, together. They're a pair, and they're reciprocals as well. So instead of having adjacent over hypotenuse, I get hypotenuse over adjacent. Okay. I love triangles because what we just talked about tells you how to work with them in their entirety. Right triangles, anyway. If I know SOHCAHTOA and I know the Pythagorean Theorem, I can do almost every trig problem with triangles. It's good news. So we're going to do a trig problem. All right, so we have an angle theta. I actually put this angle theta at the top on purpose because I want you to understand theta can be anywhere except the right angle. We're not doing the theta as the right angle. It needs to be one of the acute angles. So it is this angle here at the top. You notice that we've got two of the sides in there, 2 and a square root 5. We're missing the third side, and the question asks us to find the values of the 6 trigonometric functions of the angle theta in the figure. Now, if you'll remember this previous slide, in order to find the 6 trig functions, I need the 3 sides. And I don't have all 3 sides in this problem listed so far, but I have a formula that will allow me to find it, which is
A squared plus B squared equals C squared.
Pythagorean Theorem, a squared plus b squared equals c squared. So, let me ask the one that has no choice. What is c in this problem?
Square root of 5.
That's square root of 5. And I love squaring square roots because they cancel, yeah. I don't care whether you call the missing side A or the missing side B. It doesn't matter. I'm going to call it A just because it's listed first, which means what's B?
2.
2. Do not forget, there's squares on each of these terms. So I have A squared. What's 2 squared?
4.
4. What's square root 5 squared?
5.
5. That means A squared is what?
1.
1, because I can subtract the 4 from both sides. Now, in this case, if I kind of forgot that I had a square root, it wouldn't hurt anything. But normally it will, right? This actually tells you what A squared is, and I'm supposed to find out what A is. So I am going to take a square root. It just so happens that the number I'm working with, what is the square root of 1?
1.
It's also 1, yeah. All right, so I've got my 3 sides of my triangle. All right, using that angle theta at the top, sine should be the opposite. What's opposite here? 1 over the hypotenuse. And what's a hypotenuse? Square root of 5, and we run into our very first problem of the day. In trig, and this is not always an in every math class from here to eternity kind of thing, but in trig, and with this book in particular, and for my class specifically, you will not leave square roots in the denominator. Okay? No square roots in the denominator. We have to do what's called rationalize the denominator. So how do we get rid of the square root 5? Perfect. I think you guys have done this before. We multiply the top and bottom by square root 5. So now I have a square root 5 on top. And what is square root 5 times square root 5? 5. And beautiful things happen, and it's exactly what I want. Now I'm going to pause here for a moment, and I'm going to put cosecant next to it. Why would I want to do cosecant next? Yes, and by opposite you mean reciprocal, right? Now, I don't want the reciprocal of square root 5 over 5. That's really not all that helpful because then I'm going to have to go rationalizing again. I would really like to take the square root, not square root, the reciprocal of this expression. Because what's the reciprocal of that one? It's just square root of 5. If you want to write square root of 5 over 1 and then simplify it, that's fine. But you certainly wouldn't have to. It's just square root of 5. No rationalizing needed. So use the description of sign that's helpful for what you're doing. All right, let's do cosine. What is cosine in this case? Well, it should be adjacent, which is 2 over the hypotenuse, which is square root 5. And we have to repeat the process, right? We have to rationalize. So before somebody asks me, because somebody's about to, do I have to show the rationalizing square root 5 times square root 5 business every single time? No. If you're comfortable with knowing how you're going to get to the next step, you don't necessarily need to show this piece, okay? But you do need to show that the original one was 2 over square root 5, and that if you rationalize, you get 2 square roots of 5 over 5. All right? So which one is the most natural one to do next? Secant. And secant theta, if I want to use the most convenient form here, would be using the 2 over square root 5. And I think TJ over there, or Michael, one of you guys is the one who just told me that I can get that as square root 5 then over 2, right? Okay, the last one that I have not done is tangent for SOHCAHTOA. Tangent theta is opposite over adjacent, which in this triangle means it's going to be what? 1/2. I don't even have any square roots to deal with. How nice. And then cotangent, which is my 6th trig function, the only one undone at this point, would be what? 2. Questions? Okay, I get the feeling you guys, at least most of you, have seen this before. Now, this is a little different because they didn't draw me any triangle. They didn't tell me anything about any triangle, and yet they gave me some information that I can use. This question asks, use the definition to find the values of the 5 remaining trig functions of the angle theta. Okay, there's one that I can do without any work. Which one? Cosine, because cosine and secant are reciprocals, right? So I can do the cosine without really much work. What would the cosine of theta be? 1 over 3. All right. Now, in order to continue, there's lots of ways to continue. The only one we've talked about so far are triangles. And triangles are really convenient and very friendly and nice to use, so that's how we're going to start. We're going to draw a triangle. Okay? I need to pick an angle theta. I'm going to put it in the bottom left-hand corner. You can put it wherever you want. What I know is I know something about secant and I know something about cosine, and cosine has this very nice adjacent over hypotenuse form that I sort of remember. I always remember sine, cosine, and tangent. I don't ever really remember the other 3. I just figure them out when I need to use them. Okay? So cosine is adjacent over hypotenuse. Well, the hypotenuse is going to be what then in this problem? 3. Which side is adjacent to where I've written my theta? The bottom. So I'm going to put that in there as 1. Very good. And just like the last problem now, I need to find the third side. Okay, so I'm going to use my handy-dandy, I want to say notebook, but that's from Blue's Clues. So how about handy-dandy iPad? All right, so I've got a squared plus b squared equals c squared. I'm going to call a the side that I know, it's 1. B is the side that I don't know. And then c is 3. All right, so what's 1 squared? 1. 3 squared? 9. And now I would find then that b squared is 8, and I square root. And I have another problem of the day. I have square root of 8. The problem, quote unquote, with square root of 8 is that it's not in simplified form. So we look for anything that we can factor inside of there. So how does 8 factor? 4 times 2, or 2 times 2 times 2, however you think about it. So if I have square root of 8, and it factors as 4 times 2, another way of writing that is square root of 4 times square root of 2. And what is the square root of 4? 2. So a simplified way of writing this is 2 square roots of 2. Okay? That's mathematically simplified. That doesn't mean that you like it any better. It's just what it is. Okay? All right, so let's take a look. I've got 2 square roots of 2 then on this opposite side of theta. So let's do sine. What will sine of theta be in this problem? Good. And I like that one because it's already rationalized in the denominator, right? But right along with sine, I would do cosecant. So what would cosecant be? 3 over 2 square roots of 2. And do I get to leave it that way? No. What do I do to rationalize it? Okay, so one thing I wanted to sort of make sure that you were aware of is that I don't have to multiply by the whole denominator. I just multiply by the square root portion of the denominator, right? So this would end up giving me 3 square roots of 2 over what?
4.
4, yeah, because I already have this 2, and then the square root 2 times square root 2 is going to be another 2, and then I've got 2 times 2 is 4. All right, I got a couple more. Tangent, what will tangent be?
2 and 2. So 2 and 2.
Actually, just 2 square roots of 2, won't it? Right? Because it's opposite over adjacent, and adjacent equals 1. And I'll put the cotangent beneath it on my screen since I'm out of space beside it. So what will cotangent be before we rationalize anything?
1 2 over 4.
Okay, so this is 1 over 2 square roots of 2. And then some of you are already jumping into the rationalizing part, which is great. So when I rationalize, I've got square root 2 over 4. Okay, any questions on that? Okay, that is where we need to pause for today.